All right, this is our learning target for our waves unit on the difference between digital versus analog. This was not on your test, but it is still a good learning target to make sure that we understand. So let's watch this video to help us understand a little bit about waves and learning targets. All right, so the first thing is it's important to understand that analog and digital are both considered waves, but the most important thing is all of these waves that you see right here, even though this microwave might be coming in and giving your cell phone a message, the wave itself is analog. But when your phone decodes it, that is digital. So let's show you the difference between that. So going right here, digital and analog are both waves. Analog is a physical measurement. So it's like basically the actual wave traveling through a space. And you don't need a computer to decode it. Digital is kind of it's like it's a wave, but the wave is a computer that decodes the wave and it puts it in measurements of 0 and 1. So let us show you how that works. If this is your original sound wave, like a person's voice, and it gets traveling through, I could record it on some old measurements, like maybe like a tape recorder, like an old V8 tape recorder. So if I had an old tape recorder, or like even a vinyl record, it might come out kind of fuzzy. So there would be interruptions to the wave and it would just kind of sound like not the best quality. But as we look right here, if this is the original wave and this is it fuzzy, if you have a computer that decodes it and puts it in points of a 0 or a 1 value, you would get a very straight wave. So this is your digital wave and it's very straight. And it isn't a real physical measurement, but it's digitized to give it a value of a 0 and a 1. So you can notice that our technology has changed over time. So on this side of the screen, this would be an analog type technology because you have the actual physical measurement of it. This computer uses decoding, so it is digital. So does your iPad, so does your cell phone, so does this digital camera. It's actually putting the wave value in distinct measurements over time. So there are some benefits to analog and digital depending on what's happening. Analog waves are a continuous signal and it's a physical representation, right? So digital is discrete and it has signals generated by a digital modulation. So it's nice. Analog benefits is real time, like talking to someone. That is using real analog thing, or seeing someone. Those are real physical waves that you are actually tangible in the presence of. A digital signal is going to happen in a computer. So a digital signal can be like a cell phone getting a text, right? So is this nice to be able to talk to someone? Of course it's nice to talk to someone in real time. But is it nice to still get a text when you can't get an analog? Of course it is. So they have different benefits. We don't have to worry about that part, but here's an example. Your human voice in air is analog. Computers, CDs, DVDs, those are digital. When it comes to technology, analog technology records waveforms as they are, but digital actually puts like a number value, like we talked about here, and makes them all cleaned up. So if you had an old VHS tape, so let me go into here and just type in a VHS tape. You guys all know what a VHS tape looks like. That is analog. This is all analog because it actually records it on the strip. It's like a physical measurement. So the same thing is true of a cassette tape. This was analog. It actually records it on that ribbon that goes through it. So this is the ribbon inside of it. So that's like older technology before 1990s, like the 1980s and before that. Another one could be vinyl records, for example. A vinyl record has these grooves and they have little bumps in them, and so you can record onto them, but your sound quality is going to be really, really low. So with the data transmission, anything that is coming through in a physical wave, like a microwave or a radio wave, those are analog, but when it gets recorded and processed, if it gets processed by a computer, it's going to be digital. Another example is bandwidth. Analog is really nice because there's no bandwidth that it requires. Like you can just send out a radio wave and that bandwidth doesn't take up a lot. However, the problem is you don't have a guarantee. Well, sorry. The problem is that the signal might be distorted coming in, right? So if you're going to have digital, you need more bandwidth. So like Utopia always boasts that they have 250 megabytes of bandwidth, so that you can not only have one digital device taking in like waves, physical waves, like analog waves, they will actually have lots. Your memory stored in analog, you can't get very much on these old things. You can't have tons and tons of stuff recorded because it's all measured physically. However, if you have a digital world, you can store a ton of memory, like in a cloud, like a Google Cloud or an Electron Cloud or whatever it is that they call it. So those are binary bits. They're super, super small, so you can have a much larger storage. Analog does create a lot of power. Digital doesn't take much power because they're dealing with zeros and ones. Analog usually doesn't cost very much because you don't have to pay for a computer to decode it. Digital does cost a lot. Errors, there's a lot of errors in analog. Digital has free observations. So if you were going to continue this based on some of the information that we just talked about, some of the important things on analog would be that you have low bandwidth, and it can happen in real time. But the negatives about it is that it draws a lot of power and the message is unclear. So you can have a lot of mistakes because the wave gets kind of bumpy like this, and so you can't hear it all. It gets distorted. Cell phones, they're very nice in the fact that they do not draw a lot of power, and the message is super clear. You can get a very clear message. The negative about digital is it does require more bandwidth, and in addition to that, it requires a computer to decode, so it is usually expensive. I hope that clarified digital versus analog for you.